Okay, so the name of our presentation today is When Human Resources Meet NLP and AI. I am Alejandro Castañeira. As Cornelia mentioned, I am the principal data scientist at Janzz.technology. Here's the agenda of today's description. This is the list of topics that we'll be discussing. So we will be starting with the company description, who is Janzz.technology. This is a Swiss technology company which specializes in job parsing and the treatment of digital skills in job markets. Our customers are mostly governments, big employment service, where they are currently using our system in several regions across Latin America and Europe. We are going to start speaking a little bit about the different challenge that we have in today's labor market, especially in the recruitment process. This is a huge market. It's a 250 billion job market where they're still missing a lot of automatization. These are real numbers from different sources, from LinkedIn, Ideal, and fMRI. Resuming a little bit, the current situation, even today in 21st century, in the human resource system, only 70% of the, let's say, job seeker platform are really using automatic data capabilities. So there is still a lot of room for improvement in this sector. We are going to see here by example, these are typical mismatches of daily recommendations that we get from job seeking portals. These are by example, somebody recommends, as you see here, for an occupation, like you have your profile and you are graduated in human resources and international relations. You can get some very weird recommendation like meet industry expert or travel agent or, I don't know, social evangelist. These are still happening after all the advance that we have done in this instance. So we are going to narrate how we are solving this. For the moment in Janzz.technology, we are going to start speaking a little bit about the data representation that we are using for represent job description and resumes. Let's say that we have our own proprietary job representation and CV representation that we call a Janzz. Let's say that this is a Janzz vector. Well, we can see here there is a compendium of categories like the occupation, function, specialization, skills, soft skills. So basically, we are going to transform a resume or a job seeker in one of these vectors which have these categories. This will allow us we can compare them job and CVs together in a shared space. And we can have an explainable score. So this is highly explainable, is intuitive, its structure is less prone to bias because we only consider categories which are really adequate for matching. So let's say the things that you acquired through your education career. And then we can have a score, which is completely explainable, and you can see which soft skill you are missing or which education you are missing and how you can overcome this situation. So if we take a look, if we have two vectors, so how we can compare like occupation term, how we can compare how similar is an occupation to another occupation of a different skill to a different skill. We cannot just assign numbers to all of these different concepts. We cannot say software engineering is a number 3 and technology engineering is a number 2. We must find a more robust way to address this problem. So the approach that we have followed so far is using knowledge graph. So basically, we can address the similarity between occupation-related term with the similarities with the correspondence that they have in a knowledge graph. So we see a small sample here of anesthesia nerve and critical care nerve. If there are siblings under a branch of a knowledge graph or they have some father to children relations, we can assess the degree of similarity that these two concepts have. In this sense, we have built our own multilingual ontology, which is by the date, let's say very humbly says the biggest knowledge graph representation of HR data that we have so far. This has been built in a mechanical Turk way. It has been built like in a Swiss way. It's completely hand curated over 10 years since Janzz.technology started. So basically each term and each relation that you find there, like this is a very delicate domain, it should be completely assessed by domain specialized curators. So we don't use any type of semi-supervised taxonomy creation. It has been completely, we have hired a specialized curator in several domains, and they are the one who populate in daily basis this knowledge graph representation. So in a broad sense, when we are going to describe a complete end-to-end HR recommendation system, like that's the one we are running here in Janzz in production. So basically we have sources, two different sources, CVs and vacancies. We are going to transform these sources into the vector that we call Janzz. So this can be directly comparable. Each of these Janzz is a combination of ontology concepts. So you have each Janzz is just you have a different number with different ontology concepts for occupation, for a skill, and so forth. Then we are going to index this in Elasticsearch in there or a PostgreSQL database. And then we can query this and get a confidence score, which they are highly explainable, and you can see in which index you have a higher score or a lower score. And you can make some analytics and some recommendation basis on these results. We also have the possibility to adapt this to external search platform like Indeed, by example, when there is no Janzz creation process at the moment. They just have keyword, like the typical approach that we had several years ago that are keyword-based, but can also be integrated. So what we're going to do now is are going to explain each of the different components to get to this recommender system. And we are going to start by the parser. So in order to structure HR data, we need to have some automatic mechanic which they can extract and process variable input and give a set of entities, a set of categories with different granularity. In this purpose, we have developed our own system, which is the Janzz parser. These are some of the features that are available in the parser. It can process more than 40 languages. It can extract a different set of entities and can also approach some different granularity levels. I am now going to discuss several NLP methods that we have used that we have integrated into this product. So let's start with the name entity recognition system. So basically the first step when we are parsing a CV or we are parsing our job description, we want to extract the most relevant entities, which will be in our domain, occupation, function, specialization, and so forth. Then this is the typical task of name entity recognition. This is the current architecture that we are using so far to address this problem. So basically, we have a sequence leveling model on top of our own in-house pre-trained language model. So what we did is we took some already available transformers model, like BERT, XLMN, depending on the language, and we have pre-trained them in our own domain, so in HR corpus. This gives us way more better scores than just taking one of these models from scratch and fine-tuning it. So first, we pre-train with a lot of data. We have scraped data in multiple languages. Then on top of that, we just train a CRF or a typical sequence leveling model, and then we can have our named entities. After we extract these named entities, we are trying to put like higher granularity. So we are not just extracting the entities. We want to say, by example, in which level you make a different skill of are you a bachelor degree, you're a PhD, how many years of experience do you have? Is mandatory, it's nice to have. So in this case, all these entities, they also have a different type of granularity. For this, after we extract the named entities, we are going to use some Selfattention Network. We will have first like also a pre-trained multilingual transformer encoder, let's say XML Roberta or multilingual BERT or this style multilingual BERT. Then we have the entity, and we are going to concatenate left and right concepts. We are going to pass through some self-attention layer with multiple heads. This is very similar like to adding another transformer block on top of a transformer. This is the same mechanism that transformed blocks use. There are some self-attention layer with multiple filters. And then we are going to do a max pooling, and we have a typical classification, a feed-forward classification at the end. This will give us, like, for each skill or for each occupation and concept, which level did we have and which are the different granularities for these specific entities. Actually, we do this for many entities. Like for language, we extract language, oral and written. For experience, we extract duration, we extract industry, we extract from education, we extract the level of the education, and so forth. So this can also be applied to also other problems if you want to use this architecture. Then there is also other typical NLP problem that task that we can use, which is to extract the relations between named entities. Here we are going to extract the duration and relation between companies, working position. For this purpose, we are going to use a graph relation extraction model. In this task, we cannot just assume that the relations between two entities are just based on these two entities itself. So we need to build a graph model when all the entities are modeled there. So basically, we have an encoder. We can also use a pre-trained encoder from Hugging Face or whatever encoder you prefer to have. And then we are going to build a mention graph over each of these entities. We are going to group them. And then we are going to have an entity level graph on top of these already defined entities before passing this to a classifier to make a single level prediction. So this works relatively okay because it can consider not only local concept, but also context around the entire document, which is adequate for our use case. So we have one more steps that we want to address before transforming this into a structured representation. We have many ways to describe a given term, like Java, for example. We can describe Java as Java programming, Java coding language, Java skills. So the idea here is that we want to normalize this term into a proper canonical representation, an ontology concept. So for this purpose, we are going to use semantic similarity encoders, like, let's say, the famous universal center encoder or sentence transformer, depending on your language that you are addressing. And we are going to first fine-tune them a little bit in our specific domain, where there are several ways of fine-tune this pre-trained encoder. So they will allow us to compute the cosine similarity between the term that we extracted and the canonical representation that we have in the ontology. In the case that these are higher than a certain threshold, we can consider that we are speaking at the same term, and we can transform we can transform each of these terms to their canonical form. So later they can be used to matching. Maybe you have been wondering how do we collect data for all this process? So basically we use our Prodigy. This is our manual annotation tool from the Explosion AI. You know them, I assume most people know them very well. We use them as the data collection for all of these tasks that I mentioned so far. We basically collect by hand, we collect each day basic, we collect data, and we train our model without news data while we iterate through this process. This is a very good annotation tool. If you're not familiar with it, we recommend it. So this is a constantly iterative process where we are going to, first we are going to ingest the data, let's say from job portals of job aggregator. We are going to process this data. Then we have our domain curators here and in the company that they, let's say they train this system for name entity recognition. They collect this gold standard, they highlight the name entities, they also highlight the granularity levels. With this data, with this gold standard, we train our models, we iterate through them, we see how they are performing with cross-validation and some measures that we use to test the performance. And then if we have better models than the one we already have, we deploy them to our solution. So we do this through this iterative process. The domain curators, they are always working over the last state of our models so that they can see what are the model predicting so far. So it's a continuous loop, as we see. And then this is the actual prototype that we ship to production. So after we have done our processing part, after we have already structured the data in somehow, we are going to index this in our search engine, our match engine, like we call Janzz SME. So we have two ways to index this table. So we have an all matching version, which is use PostgreSQL. So basically, we are going to index this in one of these Janzz tables, where each offer or each resume is a composition of the ontology concept that this object possess. Then we also have an Elasticsearch index where we try to replicate this process, but with Elasticsearch documents. So we have a collection of documents. So each resume can be expressed like which are the skills, which are the CIDs of the skills that this individual possess, or which are the education level. So when we index this in Elasticsearch, this is relatively fast. It's way faster than the Postgres alternative. And this allows you, like Elastic allows you to make some, have more customized queries. This allows us to have a lot of flexibility in this step. So in search time, in inference time, we have a new processed document. Let's say that we have a new CV of a new job description, which is already structured. Then we are going to expand this through our ontology. The idea of expanding this is that you are not only searching for your skills that you are listing in your resume or in your job description. When we expand, we also search for similar concept in the ontology. So basically, if you are a Python developer, maybe you know a little bit oriented programming, or if you work in Java, you can know a little bit about JavaScript. So we use all of these relations to expand our search, and then you can match and you can have further opportunities to find related and attractive matches for this candidate or job offer. So we search for this expanded Janzz, as we call it. And then we are going to query this against our index. So then one thing to notice here, when we query these queries with our index, our intention is just to give a ranking of the candidate. We are not trying to, as I say, we are not in the hiring, we are more in the recruiting side. These are not necessarily the best candidate or job description, but these are the most likely to be the good ones to call for an interview, or these are very good ranked ones. The idea with this is that you don't miss opportunity. If you are a job seeker, you don't need to be like querying around, searching for keywords in a web browser. You just put your CV there. It will automatically expand it, transform it, give you all the grandparents, children of your concepts, of your skills that you have in your resume. And then it will search for all the opportunities for you in order that you don't lose any possible job vacancy because you didn't input the right term. So basically, this is the idea of this. You will get a good ranking. Hopefully, you will not omit any opportunity from both parties. And then we are going to show you a small demo of how this works in production before showing some reference cases. We're going to show a small demo here. I don't know if you see my screen. So let's grab a CV.
Looks good.
You see? Okay. So we are going to, and now I just upload the CV. It's going through the whole process of information extraction. We are transforming, we are normalizing, we are linking to the properly ontology concept, everything through the parsing. And then we are going to see how we can iterate with this in the matching engine. It will take a few seconds. So we have a CV here. It was already extracted. This, what we see here, are all the named entities. By example, this candidate have proficient web designing. You see, they have web designing, but not just web designing. It has level 4, so basically, have more proficient in this skill. We can see all the other skills that he ranks that he has. These are all normalized. These are all ontology concepts. We can see here also the soft skills. We see that, by example, he has very good communication skill and team working skills. He copes very well under pressure. He's proactive. We see all the different language with the levels that he has in all of this language. He speaks several languages, as we can see. With the level, if we see here, it's very interesting. Like, he doesn't write very good. He's advanced in most of the language, but he doesn't write very good in German, which is a surprise. But yeah. And then we also have their educational degree, what he has pursued, master in philosophy, which degree, which level, bachelor in philosophy, which this level. This was automatically normalized. And we can see his experience and how many years he has in each position. So basically, he was working more in marketing oriented. So he also did some basketball playing and writing for a magazine. In this case, he didn't include any authorization. So now we can try to match these candidates. We have a small test account here with some job descriptions. Let's try to match this candidate and see which position we can find from him. So we can see here, this is the ranking for the possible positions like job offering for this candidate. We see the score here. where I see that we can click in one of these score to see why he's ranked so, which they give this score to this opportunity. By example, in the left side, we can see the criteria that they match. Here we can see what it wasn't matched from the source, I mean from the candidate. And in the right, we can see what didn't match from the job description. So by example, if we see here in the left side, if we see in the occupation, we see that basically he is a marketing manager, but they are looking for a marketing specialist, and this specific field they match 50%. This was all related by the ontology, because as we mentioned before, we are searching for the similar terms in the ontology. So basically in the ontology, they are 50% related. We also see the same behavior with the skills. By example, he has the skill web designing, but they are looking for somebody who have web content and social media presence, which is 50% similar. He knows a little bit, he knows PHP, but they are looking for somebody with website development projects, so it's 1/4 of similar. He has, social network, but they want something with web content and social media presence. Let's say this is 30% because this is not very specific. So Adobe Premiere Suite, Adobe Creative Suite, and we can definitely have an explainable, like explainable results. We can search and iterate through all of these match explain, and we can see why you are giving this a score or not. So there were previous approach to trying to match resumes and job description just purely based in NLP techniques like TFD of BM25 of so forth. Also, they build some gold standard data sets where they train network to predict this matching. And I don't think this is accurate. And I think like for data science perspective, nobody would like to be ranked higher or shorter because like some feed-forward layers, they put you in a higher position. Also, the gold standard for this data set to create these data sets is not very accurate because you can never know what was really a good hire. Maybe it was a good hire, but then the people doesn't fit in that company organization. So there is really no way to build this in a way which is completely machine learning oriented, is completely explainable. So we think that this approach that we have taken is like a combination of the best of both worlds, when we have many, like a successful pipeline of good practice in NLP or in machine learning, but at the end they give you something that you can interpret it, because these are very unbiased and interpreted results. I'm going to show you a little bit more about the flexibilities. By example, we can, I don't know, we have a lot of customization, like one position with a higher education level. We see our list can change, or more senior position for several years of experience. Or we can also search for the brand wage. Let's say I noticed that this candidate speaks several languages. So he wants to work in a position when he can speak several languages. And then if we search for this and we look here, we have found somebody who, some place for him where he can excel in all his language skills. So this gives us a lot of customization. You can click each of these opportunities score, and you can see what's missing for you and what you can also try to do different for you can have a higher score. Then we also have this possibility to search in internal search. Let's try to search. Like I said, we can couple external searches. We are going to couple Indeed in this case. We can search position for this marketing manager in Indeed. Like the ontology is multilingual, we also search across different concepts. We not just search in the same language. This concept in the ontology, they have translation in all this language, and that we can find result in other language. By example, you are finding here a marketing manager in COP, Dietilcom, well, they have open position, where the job description, I think, is in German. Yeah, the job description is in German. So you can click here, you can go to the job, and you can apply for this digital marketing position. So In the matching system, you can also customize a lot from both sides, not only from jobs. We can also import jobs. Let's try to import a job. Let's try to find a job in Indeed. I don't know, Zurich. Let's try something which is a little bit difficult. I don't know. This one looks like a mess. Yeah. So we can also do the same. This is also processing. So here we see in this, we can see all that was extracted from this job offer. We see the experience, 1 for 3 years experience. Now we can also search in our matching. Oh, sorry, this is an offer. Oh, these are like, I think I don't have, oh, sorry, I don't have resumes in this account. So basically these are also matching with job description. But I wanted to show you a little bit about the data collection part that we have here. So this is how we collect the data in Prodigy. For example, you can upload files. And you can parse them. So we are going to, this is how we collect data on the daily basis. You see, we have a resume, and then we can annotate it. You see all that was extracted, that was generated. We see all, these are the current stat of our deep learning model, how they are predicting these entities. So and we can make some correction in case that he missed some skill or some education and so forth. We can see all the different levelings that we have that we was mentioning before, like to leveling skills. We can say which is the proficient level of this skill, if it's good handling, highly skillful. We can extend this to all our different granularity levels that we use in this process. This is done daily by daily curators. It's working so far very good in production. I'm going to show some reference cases I wanted to show here from customers and government that they are using our systems. Like maybe this will go to the beginning. So like the Norwegian government, Albertit Plus, this platform in Norwegian is completely powered for our system. They also have, you can also use this service for integrated analytics. You can benchmark labor employment markets, how they are behaving. And you can identify educational trends or skill trends that you need to adapt, how to adapt to current markets. And we can also see that we have other reference cases from Latin America, like Paraguay, Parempleo, Ubicanica jobs, which is more recently in Nicaragua, so forth. And I would also like to mention some pretty good Janzz.technology papers that they were reading, that they can share another vision about today's employment services and job markets. If somebody is interested in this, you can find this in our webpage. So I think this is most of the time for our presentation. Yeah, I think we should go now to the Q&A.